Mein Name ist Michael Graz, ich bin Geschäftsführer von NeemBiotech, eine Biotechnologiefirma der Gruppe Zaluvida, die basiert ist in Wales und Großbritannien. Our research is quite specifically based on the communication between bacteria in our first project. And bacteria communicate in order to be able to form biofilms, because as they speak to each other, they activate certain programs within the cell that tell the bacteria to produce mucus, to produce the factors that make them disease-causing. And what we do is we interrupt the signals. Bacteria actually communicate with chemicals, and we interrupt that chemical signal. And by doing that, bacteria don't know that they've got friends close by, which means they're not going to produce the mucus that's going to form the biofilm. They don't start the programs that make them dangerous, and it leaves them vulnerable to normal antibiotics, which otherwise would have much less of an effect. And that process would mean that a patient would need to take a lot less antibiotics than they usually do. And in combination with our treatment, should be able to clear the infection a lot faster too. And then what we're proposing is very much like a cystic fibrosis patient already does, but taking ongoing amounts of antibiotics, that by constantly maintaining a low level of the compound that we are developing, that they prevent, in the long term, from bacteria ever forming a biofilm again, which would mean a lot less infection, a lot less inflammation in the lung, which is a major problem for the patient, and in the long term, a lot less time in hospital, and obviously a lot less antibiotics that they have to use. So our first program is very much about using our compound in combination with the standard treatment that a patient would get. The second generation is about a combination of our compound with an antibiotic, so that the patient doesn't have to take more than one thing. Our third generation is very much about looking at the disease rather than an infection during the disease. And the idea is to reverse the effects of the gene defect, not by any genetic mechanism, but by affecting the cells in the lung as a whole, to reverse the negative effects that are caused by the gene defect. And you will have to understand that this is very early research, so I'm not allowed to say more, so don't affect where we are today. So our obsession with garlic is really around the fact that the original molecule that we worked on was first identified about 30 years ago in garlic. Well, it's not directly found in garlic. It's actually a product that is formed from an original molecule that you find in garlic. And some researchers in Denmark that actually had their research funded by the Mucoviscidosis Institute of Germany discovered that this molecule interrupts the chemical communication with bacteria. Now, my very, very clever colleagues in chemistry developed a way that you don't need the garlic, but you can still create the same molecule. And so we use, the fundamentals that were found in nature, and we've now converted them into something that we can easily reproduce, that we're not dependent on the world's garlic supply in order to be able to produce our drug. The smell that you get when you cut into garlic is based on sulfur. Okay, it's a combination of schwefel, and we're not taking that away. So whether you make it from garlic or whether we make it our way, it's still going to smell like garlic. Although the way we do it is in such a way that by the time it gets to the patient, it no longer smells of garlic. The approach is, if you consider the fact that you want to get into the lung where the bacteria are, so what makes the most sense is to get directly into the lung. So our approach is actually a powder that you will inhale, which is very common in the cystic fibrosis population. They're used to taking tobramycin as a dry powder and with a thing called Toby. There is colistin, which is available in parts of Europe, which is a dry powder. So we're trying to use a very, very similar route to something that the patient is already used to, so that it doesn't detract or add something new to their treatment regime.
Der erste Ansatz ist, eines der Hauptprobleme bei Mucoviscidose-Patienten ist, dass in diesem zähen Schleim, der sich in der Lunge bildet, leider sehr schlimme Bakterien ansiedeln, vor allem der Pseudomonas-Erreger. Und dieser Erreger beschützt sich dann gegen Antibiotika, indem er einen Biofilm formiert. Das ist, wie muss man sich vorstellen, die sitzen dann unter einer Decke und die Patienten müssen im Leben mehrere Kilo von Antibiotika zu sich nehmen, die zuerst diesen Biofilm durchdringen sollen und dann eben den Bakterien den Garaus machen. Und unser Ansatz kann eben diesen Biofilm durchdringen und dann das sogenannte Quorum Sensing, will heißen, die Bakterien kommunizieren miteinander und werden dann natürlich virulent und attackieren. Wir nehmen denen quasi das Mobiltelefon weg, sodass jeder denkt, er ist alleine unterwegs. Und dadurch kann man dann in einem ersten Schritt mit sehr, sehr geringen Dosen von Antibiotika diese Infektion eliminieren. In einem zweiten Schritt würden wir das dann kombinieren mit Antibiotika, weil ja ein Mucoviscidose-Patient, wie Sie wissen, mehrere Stunden täglich inhalieren muss und Übungen machen muss, was für die Lebensqualität nicht toll ist. Und dann der heilige Gral, also unser drittes Produkt, ist dann das, was wirklich die Krankheit eigentlich heilen wird, nicht im Gen-Sinne, sondern einfach alle Symptome reversieren wird. Also das heißt, dass dann der Mechanismus, durch welchen eine gesunde Lunge die Schleimbildung verhindert, wird dann wieder aktiviert.